There, welcome to edupediaworld.com. You're watching the videos on quadrilaterals. So in this video we'll discuss some more questions related to quadrilaterals, so which are very important from the exam point of view. So you have to watch this video very carefully. So let's discuss the first question, the question number 1. Now in the question number 1 it says that in a parallelogram ABCD, 2 points P and Q are taken on diagonal BD such that DP equals to BQ, means this side equals to this side, and we need to show that triangle APD is congruent to triangle CQB. So let's see how we can prove this. So first of all we need to write given. So it's given DP equals to BQ and ABCD is a parallelogram. Now so let's discuss the proof. So first we need to prove triangle APD is congruent to triangle CQB. So consider triangle APD and triangle CQB, means this triangle and this triangle we need to consider. Now so in this triangle it's given DP equals to BQ, so it's given. Now we can say that this angle equals to this angle. Why? Because these two lines are parallel, since ABCD is a parallelogram and BD is a transversal. So we can say that angle QBC equals to angle ADP. Why? They are alternate angles. And why they are alternate angles? Since AD is parallel to BC and BD is transversal. Right? Now we have two conditions. Now third condition, we can say that BC equals to AD, since ABCD is a parallelogram and opposite sides are equal in parallelogram. So we have three conditions, 1, 2 and 3. So this side and included angle. So this side and included angle. So we can say that triangle APD is congruent to triangle CQB. So this is the first part. Now since these triangles are congruent, so we can say that AP equals to QC and AP is also parallel to QC. So if in a quadrilateral, if in a quadrilateral one pair of opposite sides are equal and parallel, then it is a parallelogram. So we can say that then A, P, C, Q is a parallelogram. So this proves our this part and this part also. Now sorry, this one. Now, we need to prove that triangle AQB, means this triangle. Let me use another pen. Now, so we need to prove that this triangle, this one, is congruent to triangle CPD, this one. Now, so let's see how we can prove this. So if you see properly, so this side equals to this side because ABCD is a parallelogram, and this side is also equals to this side since APCQ is a parallelogram. We have proved over here. And this side BQ equals to DP, it's given. So we can say that these two triangles are congruent by SSS. So let's say how we can write it. So we need to consider triangle AQB and triangle CPD. So in this triangle we can say that AB equals to CD because ABCD is a parallelogram, right? And we can say that AQ equals to CP. Again, AP CQ is a parallelogram. Then we can say that DP equals to BQ. It's given. So we have three conditions, 1, 2, and 3. So we can say that triangle AQB is congruent to triangle CPD by SSS. So this is how we can prove these type of questions. Now we need to prove that AQ equals to CP. So we can say that since APCQ is a parallelogram, so opposite sides are equal and parallel, so AP is also equals to CP, so which we have already proved in this question. So this is how we solve these type of questions. So let's discuss the next question of this video, the question number 2. Now the question number 2 says that ABCD is a parallelogram and AP and CQ are the two perpendiculars from the vertices A and C on the diagonal BD. Show that APB means this triangle APB is congruent to this triangle CQ and D, and we need to prove that AP equals to CQ. So let's discuss how we can prove this. First of all, we need to write given. So it's given ABCD is a parallelogram and AP and CQ are perpendiculars from the vertices A and C on diagonal BD. Now, so let's discuss how we can prove this. Now, so consider triangle APD and triangle BQC. So in this triangle, if this is 90, so this also will be 90. So we can say that angle APD equals to angle CQB, each 90 degree, and then AD equals to BC. Why? Because ABCD is a parallelogram and opposite sides are equal. Now we can say that this angle equals to this angle. Why? Because AD is parallel to BC and BD is a transversal. So we can say that angle ADP equals to angle CBQ. Why? Because they are alternate angles. And since, why they are alternate angles? Since AD is parallel to BC and BD is transversal. So these two angles are equal. So we have three conditions. So we can say that triangle APD is congruent to triangle BQC by AAS. Why AAS? Because this side is not included. So you can see this properly. The side is not included one. So we can say that angle, angle, and side only. So we can say that now AP equals to CQ by CPCT. Now, so let's discuss how we can prove these two triangles are congruent. So let's write, consider now triangle APB and triangle CQD. Now in this triangle AP equals to CQ, we have proved, and then angle APB equals to angle CQD, each 90 degree, and then we have, can say AB equals to CD. Why? Because AB CD is a parallelogram, right? And opposite sides are equal. and parallel. So we can say that triangle APB is congruent to triangle CQD by RHS. So why RHS? Because we have one right angle and hypotenuse. So we can see that hypotenuse are equal, and we have one side which is equal. So we can say that triangle APB is congruent to triangle CQD by RHS. So this is how we can prove these type of questions. So let's discuss the next question of the video, question number 3 now. So it's very interesting question to watch, so you have to watch this question very carefully. Now in this question it's given in triangle ABC. So this is a triangle ABC and DEF. AB equals to DE and BC is equals to EF. So we need to prove that quadrilateral ABED, like A, B, E and D is a parallelogram. So we need to prove that. So now if it's given, now first we need to write given AB equals to DE and AB is parallel to DE. It's also given BC equals to EF and BC is also parallel to EF. Now, so let's discuss the proof. The first one we need to prove quadrilateral ABD is parallelogram. So if in a quadrilateral one pair of opposite sides are equal and parallel, so it's a parallelogram. Now AB, it's given AB is equals to DE and AB is parallel to DE. So we can say that AB ED is a parallelogram. So why it's a parallelogram? Because if in a quadrilateral one pair of opposite sides are equal and parallel, so it's a parallelogram. Now this is the first part. The second part, we need to prove BEFC is a parallelogram. Again it's given BC equals to EF and BC is parallel to EF, right? So we can say again BEFC is a parallelogram. Again the reason is one pair of opposite sides are equal and parallel. Now so we have the two parts. Now we need to prove that AD equals to CF. So let's see how we can prove this. Now, since we know that ABED is a parallelogram, so we can say that AD equals to BE and AD is parallel to BE. Why? Because ABED is a parallelogram, right? Then we can say that BE equals to CF. So BE equals to CF and BE is also parallel to CF. Why? Because BE CF is a parallelogram. We have proved, right? So let it be 1 and let it be 2. So from 1 and 2, so from 1 and 2, we can say that AD is equals to CF and AD is parallel to CF. So this is how we can prove. Again, if you see properly, AD, this one is also parallelogram again. Why? Because AD equals to CF and AD is also parallel to CF. So we can say that again ACFT is a parallelogram. So why it's a parallelogram? Again, if one pair of opposite sides are equal and parallel. So it's a parallelogram. So we can write why it's a parallelogram. Why? Because AD equals to CF and AD is also parallel to CF. So let's see how we can prove this one. AC equals to DF. So we need to prove that AC equals to DF. So why? So AC equals to DF. Why? Because we have proved ACFD is a parallelogram. So this is how we can prove these type of questions. So let's discuss the next question of this video and the last question, the question number 4 now. So it's very interesting question to watch. So you have to watch this question again carefully. So it's given ABCD is a trapezium in which AB is parallel to CD and AD equals to BC. So we need to show that angle A equals to B, angle C equals to D, and we need to prove these two triangles are congruent. So let's discuss how we can prove this. So first we need to write given. So it's given AB, CD is trapezium and AB is parallel to CD and AD equals to BC. Now, so let's see how we can prove this. So for construction, what we need to do is we need to extend AB to point E and we need to join C and E, or we can write construction over here. So which is very important when you are doing the questions in the exam. So construction is we can extend AB to point E and join C and E such that AD is parallel to CE and AE is parallel to CD. Now, since opposite sides are parallel, so we can say that now AECD is a parallelogram, right? Now, so if AECD is a parallelogram, so we can say that now AD equals to EC and AE equals to CD. So this is our construction now. So let's discuss the proof. Now, the proof is, first part is we need to prove that this angle equals to this angle. Now, so it's given AD equals to BC and AD is also equals to EC, since this one is given, and this is why, because AECD is a parallelogram, right? So we can say that now BD or BC, first of all AD equals to AC, and we can say that BC equals to EC, means this side is also equals to this side. Now if you consider triangle BEC, in this triangle BC equals to EC, so it's become an isosceles triangle. So we can say that this angle is equals to this angle. So let's say this angle is 1 and this angle is 2. So we can say that angle 1 equals to angle 2. Why? Because angles opposite to equal sides are equal. Now, so we can say that, let's say this is angle 3 now. So we can say that angle 3 plus angle 1 equals to 180, right? So we can say that angle 1 equals to 180 minus angle 3, or angle 3 equals to 180 minus angle 1. Now let's say we assume that angle 1 equals to x, so we can say that angle 3 equals to 180 minus x. So this is angle B. Now, so if you see properly, AECD is a parallelogram, so we can say that angle A plus angle 2 is also equals to 180, right? Why? Because they are co-interior angles. And why they are co-interior angles? Because AECD is a parallelogram. So we can say that angle A equals to 180 minus angle 2. Since angle 1 is x, so and angle 1 equals to angle 2, so we can say that angle 2 is also equals to x. So we can write angle A equals to 180 minus x. So this is also x. 180 minus x. Let's say this is 1 and let's say this is 2. So from 1 and 2 we can say that angle 3 equals to angle A, and angle 3 if you see properly is angle B. So we can say that angle A equals to angle B. So this is how we can prove this. Now the second part is we need to prove that angle C equals to angle D, means this angle equals to this angle. Now if you see properly, AE is parallel to CD and BC is a transversal. So this angle, angle 1 equals to angle C. Why? Because they are alternate angles. So we can say that angle 1 equals to angle C. Why? Because they are alternate angles. Okay, now they are alternate angles. So why they are alternate angles? Because AE is parallel to CD and BC is transversal, right? So we can say that angle C equals to x also. Now, so what about angle D? Angle A plus angle D is 180 and they are co-interior angles. So why they are co-interior angles? Because AB is parallel to CD, it's given, and AD is a transversal. So we can write angle A plus angle D equals to 180 because they are co-interior angles. So angle A is 180 minus x plus angle D equals to 180. So if you see properly, so angle D will be equals to x. So from this one and this one we can say that angle C equals to angle D. Now let's see how we can prove the last part, so which is very interesting again, so you have to watch it carefully. Now so we need to prove that angle ABC, triangle ABC is congruent to triangle BAD. Now so let's, for convenience, let's draw the triangles over here. So this is, let's say, triangle ABC, and we need to draw triangle BAD. So let's draw like this. So this is BAD. Now, so let's say how we can prove this. So we can say that AB equals to AB. So it's a common side. And it's given angle A equals to angle B, we have proved. So angle A equals to angle B, we have proved. And it's also given AD equals to BC, so it's given. So we can say that triangle ABC is congruent to triangle BAD by SAS. So this is how we can prove these type of questions. So thank you once again for watching this video on edupediaworld.com. Keep watching further videos.